All right, hello everybody. How y'all doing? Hope everybody's having a great weekend. Right now, we are going to be covering header files. It's crucial to know for our next unit, which is Makefile. For header files, the idea behind it is okay. So we're going to start something very simple. Because you have your iStream. When you go for your iStream, these parameters right here, well, not parameters, whatever these are called. These refer to the compiler files. So when I go definition, this will go to my D drive where I have my compiler file, and then we'll go into my C++ and grab my iostream.cpp. Right? This is what this means. It's a standard library. Now let's say we don't want to use a standard library. We want to make our own library. In order for you to do that, you'd use quotes. Quotes refer to the files within your directory. So you know how I am in my command argument file? Inside this, I have my add.cpp, so I can do add.cpp. Now the question is, well, what if your add.cpp was in this file? So what I can do is, right here, I can do dot dot, which is terminal. Dot dot means go back a directory. So right now I'm in my main.cpp. I'm going to say go back a directory. So I'm going to go to my midterm2, and then I'm going to do slash now go into my add. See, it already catches it. All right. So that's another way that you want to, go around directories. Let's say your file is not within the same directory. But in our case, it is. So this is the first thing. My add.cpp is empty, so this is basically including nothing for now. Right above this, I'll just include my standard library, which is my iostream. All right, and I'll have my int main. Okay, now inside my int main, let's say I want to add two numbers, and to add those two numbers, I'm gonna make a function for it. Let's say I go here, I'm gonna do int add, and it's gonna be int a and int b, and I'm gonna return a plus b. So far so good. So I'm gonna use it here. I'm gonna say, oops. Let's print it out. Let's say pass 5 and 2. All right, and this should give us 7. So you see when I compile it, it says it was not declared because this was declared under it. But if I go up here and I do int add, and I do int dash int, what this tells the compiler is that, hey, there's going to be some function that returns an int, the name is add, the name has to be the same, and the two parameters it takes has to be the same. I could put a and b here, or I could put c and d, it doesn't matter. But the point is that it takes two, like you don't even have to put anything. This is called a signature. So I'm signing it and I'm telling it there's this function that's going to be somewhere. You see when I run it now, it works fine because it knows there's a signature. You can use it within here because it will refer to this. It's called reference. This points to this and refers like, hey, this is where it is. And so when my file compiles, it runs this, then it runs this, then it runs this. Then it goes here, oh, there's add. Then it goes back to our reference. Like, oh, this reference is down here, and then it works. All right. The thing is, let's say I want to change this here. And you see, when I change this to C, this changes. However, this doesn't change. This functions the same. So why do I have to recompile the whole thing in order for me to just recompile this? It doesn't make sense. So I'm going to think, you know what? I'm going to take this and I'm going to put it in here. Fair enough. I'm going to delete this. I'm going to delete this. I have my file included. So now what I do is I do g++ main .cpp and -o main. Oh, and compiled fine. And when I do it, I return 7. And if I change this here, if I change this and I recompile, compiles fine, main. And you're going to think, oh, I'm only compiling the main, so this solves my problem. But it actually doesn't. Because the way when you include something, what it goes is it's going to go to this file, it's going to copy this, it's going to put it here, and then compile the whole thing. So that is counterproductive. You didn't do anything. You did the same thing differently. So the way to go about this is something called a header file. Here, you can do add.h. So I included this file now. I didn't include this. I didn't include this one. I only included this. Right? And you see here it says identifier add is not defined because inside here there's nothing. So now when I do int add, this is going to be the definition, the reference. When I refer it, this is basically now copying this because you know how I said when you include, it takes and it copies it here. This is now what it looks like. But you see, if I run this, it still gives me an error, undefined reference. Now it says I have a reference. of add int, but it's not defined. There's where am I referring to? So the other thing is now I'm going to tell it here, I'm going to include it, and this is called a linker, and I'm going to link them. So you see now add.h. Now add.h is here and here. This file now links between main and CPP. So when I compile it, you see it still gives me an error, undefined reference. Like, I just linked them. But the thing is, when I click up here, I am basically only doing this. That's all I'm doing, which it gives me the same error. I'm only compiling one file. So I actually have to compile both. So in order for me to use this second one, I also have to compile it, of course. You see when I run this, it compiles, and I do ./main, it works. This links them to, and you still have to compile them to. And then it links together. Now the logic on the back end works this way. I already have it set it up. This is your main.cpp, what we have. I have the add.h. I have ignore this for now. Ignore this file for now. And I also have my add.cpp. So what happens here is the file will first compile this. All right, so let me change the color. So we'll compile this, right? And this will first, we'll see something called a preprocessor. We'll see include add.h. So we'll go here, bring this in, then compiles, and it gives us main.cpp, or sorry, main.o, like this. So here, I'll just write this in text, so a little bit easier for you guys to read. Main.cpp. Oops, .o. Okay, so it returns a main.object. This is an object compiled. This is compiled. Now we're going to do the same thing for my second one. And this goes here, the compiler, preprocesses. Oh, here, well, here I'm not including, so that's wrong. Remember how we said we have to link them? So we're going to include here my add.h. Yeah, we're going to include this. And so now the compiler will go here. I'll read this, the preprocessor, grab this in here. My computer can just work. Grab this in here, compiles it, and it returns us our add.o. Okay? So see now, two different compilers, just like I did here. Compile this and compile this, two different compiling. Now we have two objects. Now is where the linking works. The compiler will go, take this, and it will link them together into your executable, which is your main.exe. Let me turn this in black so it's easier to see. This is what I run here, my executable, which is both of them. This is the binary code that your machine understands. All right. Now, when I change this here, when I go here and I change C, and I save it and I recompile, I don't have to recompile this because this is the only thing that changed. So all I have to do is actually recompile this part. I recompile this part and I just relink it. And I get rid of this link. I just recompile, I get a new object, relink it. This I don't have to recompile. And you're gonna be like, well, how are you gonna recompile one and not the other and link them? Well, this is where you'll understand in Makefile, and we'll get to it. But for now, this is the idea between headers. The other thing you should know about headers is that there's something called a guard. What is a guard? So here, I have my sub.h and I have my sub.cpp. They're empty. We don't have to fill them. We're just going to talk about the logic behind. Let's say here, I want to include my add.h, right? If I can just spell this right. You see my in sub.h, I included my add.h. And let's say in some scenario, I have to also include my sub.h here. And I have my add.h included here, and I have my sub.h included here. And now, when I compile this, I only have my .h here. When I compile this, look what happens. Include nets to depth 200 exceeds maximum of 200. So what happened here is, you see how we have include and we have include. When I compiled, this included my add.h, then inside my add.h I had the sub.h. So then it went here and it included it. But then in my sub.h, I have the include add.h. So then it went here and it included it. But then I also have my sub.h. So then I went here and it included it. And then so on, back and forth, and still did it 200 times. That is a big problem. And how do you get around this problem? The way you do it is, what I'll do is hash, and you'll say if not defined. If not defined. What is not defined? I'm going to say add underscore h, which is my file. I'm in my file right now. I'm going to say if not defined, and it's all caps underscore. That's the format. If not defined, then defined underscore h. And then this is at the end of your code. You'll say, and then end my if. After you define this whole thing, whatever's in between, end the if. What this does, so add it here, and we'll add it here as well. So we'll say, so if not defined, this will be sub underscore h. Now I'm gonna say then define. And I'll say sub underscore h. And pay attention. You see right now this gets underlined because I didn't do my end if. And pay attention, your end if doesn't take the parameter because it just ends the if statement, which is this if statement. All right. Then I save this, and now I recompile. Oh, it compiled just fine. If I run it, still compiles fine. Because the way this works is, see, if I go back, all right, if I go back here, what happens is because we have our if diff, then what happens is this will get included. That's defined now. Then we'll see my sub.h, and then we'll include this here too. Well, technically, this will get included here. Then this whole thing gets included here. But it doesn't redefine because when it goes back, it might include .h and grabs it again. It goes like, oh, this has already been defined. So it doesn't do it anymore. That's why the loop doesn't keep going. That's basically the importance of this. And there's, I believe, another way where you can do pragma. I believe just pragma end or something like this. Let's try it out. Oops, I deleted an important file. This is like a similar version of it. Let me remove this just to be sure that it works. I believe there's a parameter to it, like end or something. I'm not too sure, but there's also a pragma that I will include in the video that basically does the same exact thing. And that's basically header files in a nutshell. Okay, so I actually just figured it out. This one is pragma once, and you add it in both. And what this does is include it just once. Technically, you could actually, even in the if def, you don't have to include this twice because it already stops here and it never goes here to run this to begin with because you have run it once. But that is the other way to do if diff, which is the cleaner way. You just do pragma once, and this does the job, gets the job done.